Okay, let's dive into this. You've brought us some interesting sources today.
Hmm.
They seem to point towards this uh, intersection between math and food security, specifically looking at college-level calculus,
Hmm.
you know, integration, differentiation,
Yes, that's right.
and how that connects to energy use in food processing plants.
Exactly. The material you shared, it really drills down into a specific application. It suggests that, this abstract math isn't just theory.
Right.
It's actually a tool for tackling these very real world problems, especially how integration links to the energy needed to get food processed and ready.
So our mission here for this deep dive is basically to unpack that from your sources. How exactly does integration play a role in this whole food security and energy picture? It feels like a really solid example of applied math.
Absolutely. And what's quite insightful, I think, from the sources you provided is this focus on quantifying things that change over time or maybe vary during a process.
Mm.
Think about the energy a machine uses in a food plant. It's almost never just a flat, constant rate.
Right, yeah, like a motor starting up or something.
Precisely. It might spike when it starts, use less power running steady, maybe more, again, if it's dealing with a thicker batch of product, that kind of thing.
And this is where integration actually comes into play, isn't it? Your sources seem to be saying that to figure out the total energy used over a whole run, just knowing the machine's power rating isn't really enough.
Exactly right. Integration, fundamentally, it's a way to add up quantities that are, well, continuously changing.
Hmm.
So if you imagine a graph, power on one axis, time on the other, for a specific job, maybe heating a big vat of something for pasteurization,
Okay.
the area under that power curve, that represents the total energy consumed for that heating step. And your sources highlight that calculating this total energy, that's the application of integration.
Ah, okay. So it's not just about the peak power draw, but actually measuring and summing up the energy it really uses for a task or over time.
Exactly. And the insight from your material is that this number, this total energy figure, which you get by applying integration to real-time power data, is incredibly useful.
Also,
Well, it's fundamental for working out the actual energy cost for each batch of food you produce.
right, the cost per unit.
Yeah. And it's key for figuring out the carbon footprint of the processing stage, too. It lets engineers pinpoint which steps in a process are the real energy hogs.
So you can target improvements.
Precisely, highlighting where you can potentially optimize, make things more efficient.
And this is where it really ties back strongly to food security, I guess. Because energy, that's a major cost for these plants.
Huge costs.
So if you can cut down on energy waste, optimize how it's used through this kind of, well, mathematical analysis that directly lowers production costs.
And lower production costs can definitely influence the final price of food, which impacts affordability, accessibility, key parts of food security.
Makes sense.
Plus, there's the sustainability angle. In a world dealing with climate change, cutting that energy footprint by boosting efficiency, that's also a direct link to long-term food security. You're preserving resources, lessening the environmental strain on agriculture.
So this deep dive, using the material you provided, it really focuses on this specific thing.
Hmm.
Using integration to track cumulative energy use in food processing
Mm-hmm.
and seeing that as a practical tool for managing costs, boosting efficiency, reducing environmental impact. And all of that loops back to the bigger food security issue.
Yeah.
It really shows those calculus concepts aren't just abstract homework problems. They're quantitative tools for optimizing something as vital as, well, our food supply.
It definitely reinforces that idea that even these seemingly theoretical math concepts like integration, they have very tangible, very practical uses in engineering, food science, managing operations, providing that framework to measure, analyze, and hopefully improve these real-world systems.
It really makes you think about the hidden calculations, doesn't it? How might really understanding the total energy footprint of making our food quantified, using math models with integration, how might that fundamentally shift how we view the true cost and the sustainability of what ends up on our plates? Definitely something to chew on next time you're at the grocery store.